Alright, today we're going to talk about half-life. Half-life is the amount of time required for half of a sample to decay. So, for example, if you have a piece of uranium that has a mass of 100 grams, after 10 minutes, how much is left if the half-life is 1 minute? So we want to think about, what does that mean? It means that half decays every minute. So we divide by 2 after each minute has passed. So if you look on your notes, you'll see you have a time and amount remaining chart. There is an error on it, so you'll need to make a correction. Because it says at time 0 there are 50 grams, and then there's a problem at time 0 there are 100. So, at time 0 we have 100 grams. After 1 minute passed, we have half as much left, which would be 50. After another minute passed, we'd have 25, and then 12 and a half, and then so on down the line. So if we continue on down the line, we would have half of 12.5 would be 6.25, then 3.125, and then 1.563, and then 0.7813, and 0.3906, and then 0.1953, and then 0.0976. So at the end of 10 half-lives, or 10 minutes, we would have 0.0976 grams remaining, because we would have taken half 10 times. So again, this is the same as doing 100 divided by 2 to the n, where n is the number of half-lives. So the number of half-lives in this case, we take our total time divided by our half-life time. So our total time was 10 minutes, each half-life was 1 minute, and so our number of half-lives was 10. So you could also plug in your calculator 100 divided by 2 to the 10th power, and that would give you the same value that we got by setting up our chart. So we use A sub 0 to stand for initial mass, A to stand for the final mass. The number of half-lives again is n. And so we can say that the final mass is equal to the initial mass divided by 2 to the n. And again, for our problem we just did, that would be 100 divided by 2 to the 10th power, which again comes out to be 0.0976 grams. So what if n isn't a whole number? So if n is not a whole number, such as in this problem here, where our final mass was 5, our initial mass was 73 grams. Put units in here. Grams. What would the value of n be? And so we would plug into our equation 5 equals 73 divided by 2 to the n. So again, we always want to get our variable out of the denominator. So we would have 5 times 2 to the n is equal to 73. So I'm going to move 5 away by dividing by 5. So we get 2 to the n equals 73 divided by 5 is 14.6. Now, how do we solve for n? How do we get n, our variable, out of the exponent? If you recall, you take the log of both sides. When we take the log, what happens is the n actually gets to come down front. And so n times the log of 2 is equal to the log of 4.6. And so again, we want to know what n is, so we're going to divide both sides by the log of 2. And so n is equal to the log of 4.6 divided by the log of 2. Log of 4.6 divided by the log of 2. And that gives us 2.2. So that means our number of half-lives is 2.2. Our 2.2 half-lives to go from 73 to 5. Given that information, if we knew how much time, we could calculate the time of a half-life. which we'll do in some of our practice problems. So let's look at example problem 1. The half-life of nitrogen-13 is 10 minutes. If the starting sample has a mass of 2 grams, how much will remain after 40 minutes? So the first thing you always want to do is find your number of half-lives. So in this case, we have time. We know our total time and we know our half-life time. So if you recall, I told you that the n, or number of half-lives, is equal to the total time divided by the half-life time. So in this case, our total time is 40 minutes. Our half-life time is 10. So how many half-lives are there? In this case, there are 4. It's an even number. Makes it a little bit easier. So that would mean that our starting sample has a mass of 2. How much will remain? So what's our final mass? If our initial mass is 2, so our initial mass is 2 grams divided by 2 to the n, which is 4 in this case. So 2 divided by 2 to the 4th, and that gives us 0.125 grams. Okay. We're going to skip practice problem 1 for now. You come back to that, and we'll go ahead and go through example problem 2 with you. If 200 grams of an isotope decays to 25 grams in 24 seconds, what is the half-life? So in this instance, we're not looking for the number of half-lives, we're looking for the actual half-life. But we could determine the number first. And so we have our equation, A equals A0 over 2 to the n. So if I want to find the number of half-lives first, I plug in the information I know. I know that I have 200 grams to start with. I end up with 25 grams. We have 200 grams to start with, over 2 to the nth power. So again, I need to solve for n. So I'm going to cross multiply and get 25 times 2 to the n equals 200. I divide both sides by 25. So I get 2 to the n is equal to, excuse me, I didn't write that down, 200 is equal to 8. So 2 to the n is equal to 8. So what is the value of n? In this case, you probably don't have to use a log. You can probably figure out 2 to what power equals 8. Right, that's the third. So n will be equal to 3. You could take the log of both sides and solve it that way too. But when there's an even number, you can just do that in your head. So 2 to the third power is 8. So since n is equal to 8, and remember we learned that n was equal to the total time over the half-life time. So if 3 is equal to our total time, which was 24 seconds, over our half-life time. So again, we have to get our variable out of the denominator, so we'll cross multiply, and we'll get 3 times t1 half equals 24. So t1 half will be equal to 24 divided by 3, which would be 8 seconds. Alright, example problem 3. The half-life of iodide-131 is 8.07 days. If 25 grams are left after 40.35 days, how many grams were in the original sample? So in this case, we have both of our time values, so we'll be able to find what n is. So n is equal to the total time of 40.35 days over 8.07 days. And so how many half-lives is that? Right, that's 5. And so our final mass, it says it's 25. Our initial mass is what we're looking for, divided by 2 to the 5th power. And so we'll cross multiply, and we'll have 25 times 2 to the 5th power. And so we find that A0 is 800 grams. And technically for our significant figures, we should have 3. And so we should have a decimal point here. Or we could write it as 8.00 times 10 to the second. That would work too. Alright, you try practice problems 1, 2, and 3. Pause the video and do those, and then I will show you the answers. answers to the practice problems. Number 1 is 75.0 grams. Number 2 is 15 seconds. And number 3 is 5.2 hours. You don't have to worry about submitting figures on these. And again, they're not on your final exam. And so you don't need to worry too much about your submitting figures. If you have questions about how to enter these problems, we'll go over them tomorrow in class.